You're expecting that familiar roar, and instead you get, well, silence. Maybe a click. But the display isn't silent. It's flashing alarm code 17. Engine failed to crank.
A classic frustration, for sure.
So today, we're going to ignore that urge to just hit clear and really tear into the technical logic of what's happening.
And that's the key, because code 17 isn't just a generic, it's broken message. It's actually a very specific diagnostic report.
It's the controller talking to you.
Exactly. It's telling you, I tried to move, but I couldn't get up to speed.
And up to speed isn't a feeling, it's a hard number. That's the mission for this deep dive. Understanding the controller's logic.
Right. Because the system, it's all about the math. And for the controller, the difference between off and cranking is a very clear threshold.
Which is 40 RPM.
That's the magic number, 40.
So if the engine fails to hit that speed, the alarm sets.
Precisely. If it doesn't reach 40 RPM, or, and this is a really crucial detail in the service notes, if it gets above 40 but then drops back down during that crank sequence, bang, you get the alarm.
Okay, but it doesn't just give up on the first try usually. There's a kind of two strikes logic.
Correct. The system assumes, a cold engine might need a second kick, so the first failure just logs as a prevent alarm.
A warning shot.
Basically. It'll pause, let the starter cool off for a bit, and then it'll try again. If it fails that second time, that's when it escalates.
To a full shutdown alarm.
And that's when your phone rings.
Right. But I did see some important exceptions to that rule. Scenarios where you don't get that second chance.
Yes, context is everything. If a code 17 pops up right after an alarm code 20 or 84, those are failed to start codes, the system just assumes something is seriously wrong.
It goes straight to shutdown.
Straight to shutdown. And also, if you've just cleared a code 63, an engine stopped alarm, you only get one shot.
Okay, so that's the brain. Now let's talk about the hands-on part, the fix. The instinct is to just grab a wrench. But the manuals are really clear. Keep the toolbox closed for a minute.
Data before disassembly. Always. You need to hook up the diagnostic software WinTrack and download that Service Watch logger.
Why is that so critical?
Because you need to see what the unit was seeing. You need the voltage, the sensor readings at the exact moment the alarm was triggered.
It's like digital forensics.
It really is. You're checking if the battery voltage just cratered or if the RPM sensor was reading 0 the whole time.
Okay, so once you've looked at the data, ruled out the battery, the cables, the guide points to one very specific spot.
The interface board, specifically fuse F3.
That's a 40 amp fuse.
A 40 amp fuse. If F3 is blown, the starter is never even getting the signal to wake up. It's a 10-second check that can save you hours.
So let's say F3 is good. Data looks okay. Now we need to see if the signal is actually making the journey. This is where that continuous mode test comes in.
Right. You force an engine start in continuous and you watch the interface board. You're looking for one thing.
LED 25.
That little light is the whole story.
What's it telling you?
Well, if LED 25 lights up, the microprocessor is doing its job. It's sending the go signal to the starter.
And if the light is on, but the engine is dead silent?
Then the problem is downstream from the board.
Which brings us to the 8S circuit. The notes call it the high current harness.
That's it. You need an ohmmeter on that 8S wire. You're hunting for a push pin, a loose crimp, any break in the line.
So you're just testing for continuity.
Exactly. If that wire has high resistance, the signal from the board just dies before it ever reaches the starter solenoid.
But here's the final piece of the puzzle. What if the electronics are perfect? Fuse is good, LED 25 lights up, the 8S wire is solid, you hear the starter engage, but the engine just won't turn.
Then you've officially left the digital world. You've hit a physical wall.
Mechanical seizure.
It could be the engine itself, but more often than not, it's a seized compressor that's locking up the whole drive belt.
And the service notes mention one more thing that can cause that kind of drag.
Oh, yeah. The electric standby option.
How does that factor in?
It's a huge factor. If the unit has it, a seized electric motor or even a failed clutch adds a massive amount of resistance. The starter motor is just fighting a battle it has no chance of winning.
So, to recap the workflow for everyone listening. First, don't guess. Download the Service Watch data and check the RPMs.
Then check the power path. Look at fuse F3, then check for LED 25.
After that, verify the 8S wiring integrity. And only then.
Only then do you start putting a wrench on things to check for mechanical seizure. It's a process of elimination, from the brain down to the muscle.
It really makes you realize that code 17 isn't just an error message. It's a It's a report on a struggle between torque and resistance.
That's a great way to put it. The code is the unit telling you that basically gravity and friction won that round.
So here's a thought to leave you with. We tend to trust that mechanical funk of a starter more than we trust a digital code. But with modern diagnostics, the silence actually tells you less than the sensor data does. Trust the log, not just your ears. Thanks for diving in with us.